The universe is stranger, more marvelous, and vaster than we can truly comprehend. We are taking our first steps in exploring our solar system. Our technology has reached distant worlds. Scientific advancements allow us to uncover what lies beyond our cosmic neighborhood. Revealing extreme planets and celestial wonders shaped over millennia. Today, we journey through space, venturing into the most unexpected corners of the known universe. We will showcase the most spectacular, breathtaking, and intense phenomena in the cosmos. Mars, the red planet. Recognizable by its reddish hue, caused by iron oxide on its surface, it is one of the most extensively studied celestial bodies in the solar system. Half the size of Earth, it has captivated humanity for generations. NASA's rovers, including Opportunity, Curiosity, and Perseverance, have provided invaluable data on Mars' climate and geology. Here, we see a stunning view of Belva crater, captured by the Perseverance rover using an advanced camera. This crater lies within the massive Jezero crater, the mission's primary exploration site, chosen for its potential to reveal evidence of past life. Elsewhere, Perseverance has documented intriguing rock formations and unusual geological structures. This panoramic image was taken by the Opportunity rover at Greely Haven, where it remained during the Southern Hemisphere winter on Mars. The terrain appears reddish and rocky, with a rough texture and tracks imprinted on the ground by the rover's movements. These missions have been crucial in exploring whether Mars could have supported life in the past and in preparing for future human expeditions. Valles Marineris, near the Martian equator, is one of the largest canyon systems in the solar system. It stretches 10 times the length and plunges 3 times the depth of the Grand Canyon in the United States. In the western hemisphere of Mars stands Olympus Mons, the tallest volcano in the solar system, rising 22 kilometers, 14 miles, nearly 3 times the height of Mount Everest. This shield volcano was formed by successive lava eruptions that gradually spread across the surface. Mars has 2 small moons, Phobos and Deimos, named after the sons of the god of war in Greek mythology. Phobos, the larger and closer of the 2 moons, completes 3 full orbits around the planet in a single Martian day. Deimos, which orbits at a greater distance, takes about 30 hours to complete its journey. At the North and South Poles, icy layers contain frozen water and solid carbon dioxide, commonly known as dry ice. During the Martian summer, some of this ice sublimates into gas, only to refreeze as winter returns. Eagle Nebula. Shining within the constellation Serpens, this active star-forming region lies about 7,000 light-years from Earth. The radiation from massive stars triggers unique phenomena, such as the pillars of creation, sculpting mesmerizing shapes by eroding gas and dust. These cosmic structures stretch between 4 and 5 light-years in length, spanning a distance roughly 30,000 times that between Earth and the Sun. Composed of molecular hydrogen and interstellar dust, they contain the essential ingredients for star formation. The Sun. Although it is an ordinary star in the universe, certain characteristics make it truly unique. Thanks to NASA's Solar Dynamics Observatory mission, scientists have been able to observe its activity in high resolution. Our star is a yellow dwarf in the main sequence of its life cycle, steadily burning hydrogen at its core. This stability has allowed life on Earth to thrive for billions of years, with a nearly constant energy output. While not particularly large on a cosmic scale, the Sun is vast enough to hold 1 million planets the size of ours. times, solar eruptions reach staggering heights, nearly 8 times the diameter of our planet. During peak activity periods, the Sun releases massive amounts of charged particles into space, creating dazzling auroras in the northern and southern skies. Some of the most spectacular eruptions have their own names, such as Trebuchet, where a solar flare and a cascade of plasma were observed falling back onto the Sun's surface. Carina Nebula. Located approximately 7,500 light-years from Earth, this celestial wonder lies within the constellation Carina. The James Webb Telescope captured these images, revealing intricate details that were previously hidden within the vast gas cloud. Here, young and massive stars take shape, releasing immense amounts of energy that sculpt the surrounding gas and dust. Jets of gas streaming from specific regions of the nebula originate from intense stellar activity within its depths. Black holes. In April 2019, the first ever image of a black hole was captured, a groundbreaking achievement in astronomy made possible by the international collaboration of the Event Horizon Telescope. The focus was set on the black hole at the center of the Messier 87 galaxy, chosen for the clarity of its surrounding conditions. At the core of our own galaxy lies Sagittarius A*, a supermassive black hole whose image has also been unveiled. The glowing ring around it is an accretion disk, a swirling structure of gas, dust, and other materials moving at extreme speeds. As light nears the black hole, it begins to warp due to the immense curvature of spacetime. The event horizon marks the point of no return, where nothing can escape the black hole's gravitational pull. Beyond this boundary lies the singularity, a realm where known physical laws cease to function. What happens there remains a mystery. Some theories suggest it could connect to other parts of the universe, or even different universes, though this remains speculative. Among the largest black holes detected so far are TON 618, Phoenix A, and SDSS, each possessing masses equivalent to tens of billions of suns. Found at the heart of their galaxies, these colossal objects formed in the early universe and are capable of unleashing powerful jets of particles.
Kepler 452b.
Located 1,400 light-years from Earth, this exoplanet is often called Earth 2.0 due to its striking similarities to our own world. Positioned within the habitable zone, it orbits a sun-like star at a distance comparable to Earth's orbit, completing a revolution in 385 days. The clouds on Kepler 452b are believed to be thick and misty, blanketing much of the surface when viewed from space. With a mass 5 times that of Earth, it could generate significant internal heat, which, if it is a terrestrial planet, might fuel intense volcanic activity. If this hypothesis holds true, it would host numerous active volcanoes, with rivers of lava and towering ash plumes rising into the sky. Volcanic particles, combined with a dense atmosphere, would scatter light in such a way that sunrises and sunsets might glow in vivid red hues. If life exists on Kepler 452b, it would likely be vastly different from anything on Earth, almost beyond imagination, yet fascinating to contemplate. High gravity, dim sunlight filtered through thick clouds, and potential volcanic activity would shake the adaptations of any life forms. One such organism, Lumnivirax kepleri, or the luminous tower, could be a bioluminescent plant growing at great heights to absorb the faint sunlight penetrating the atmosphere. The planet's strong gravity gives it a dense, fibrous trunk, with deep roots that extract nutrients from the volcanic soil. Nectamista nebularis is a floating vine composed of lightweight tissues, adapted to the planet's thick, humid atmosphere. It absorbs water and nutrients directly from the air using sponge-like aerial roots. Ruminator obscurus is a herbivore with multiple stomachs, specialized for digesting Kepler 452b's tough plant life. Its skin is covered in glowing symbiotic lichens. Ignivermis lava is a giant worm that dwells beneath the volcanic surface, feeding on magma. Its heat-resistant body emits a red glow, acting as a warning to potential predators. Umbracoris is a land-dwelling creature with disproportionately large ears, evolved to detect vibrations in the ground. It navigates by sound, as the planet's thick fog severely limits its vision. OTS-44. Like a cosmic nomad, this interstellar planet drifts freely through space, unbound to any star. It is surrounded by a circumstellar disk of gas, dust, and ice, with an estimated mass about 30 times that of Earth, potentially capable of forming a planetary system. Surprisingly, rogue planets are not rare. They actually outnumber stars within our galaxy. Without the warmth of a nearby star, they are dark and frigid places, though some are believed to generate internal heat. Scientists speculate that certain wandering planets could harbor life beneath their surfaces, provided they have a thick atmosphere and liquid water within. Gliese 667 cc. This exoplanet, located about 24 light-years from Earth, is one of the most promising candidates in the search for habitable worlds beyond our solar system. With a mass 4.5 times that of Earth, it suggests a suitable size for a rocky composition and conditions similar to those of our planet. Its host star, Gliese 667c, is a red dwarf, meaning it receives dimmer light, casting the sky in a reddish hue. Due to its proximity to the star and likely tidal locking, where one side remains in perpetual daylight while the other stays dark, it could have one scorching hemisphere and another frozen.
As a super-Earth, it may feature towering mountains and active volcanoes, driven by its stronger gravity and greater mass.
Under such conditions, it is fascinating to imagine the creatures and vegetation that could evolve on Gliese 667 cc. Luminar trees, with their fluorescent trunks, emit a greenish glow in the darkness. Instead of photosynthesis, they would extract energy from minerals in the soil, while their light could guide nocturnal animals that help disperse their seeds. Luminopods would be quadrupedal creatures with bioluminescent legs, used both for communication and to light their way in the planet's dark hemisphere. Their dark skin helps them blend into the environment while also retaining heat, and their large eyes allow them to capture light in dimly lit surroundings. Stratovids combine air sacs in their abdomen with long legs, enabling them to momentarily float over rocky terrain. In a landscape filled with jagged stones and deep crevices, this ability gives them an advantage for exploration or escaping predators. Spirolumbras have spiral-shaped tails that function as antennae, detecting shifts in stellar radiation or distant movements. They create vibrations with their tails, which others of their species perceive as warning signals. Hydratophages, adapted to arid regions, extract moisture from the air using their branched tongues. Their bodies are covered in reflective scales that deflect stellar radiation, minimizing water loss. Florotherms grow luminous flowers on their fur, attracting insects that they then consume for nutrients. These are not actual flowers but modified extensions of their epidermis that emit bioluminescent light. Jupiter. With a mass 300 times that of Earth and a diameter 11 times larger, it stands as the largest planet in the solar system. Acting as a shield for our planet, its immense gravity deflects comets and asteroids, reducing potential threats to Earth. Jupiter hosts the most intense auroras in the solar system, generated when charged particles from the Sun and its moons interact with its powerful magnetic field. The Great Red Spot is a massive anticyclonic storm in the planet's southern hemisphere, shaped by rapid rotation and atmospheric composition. Though it has shrunk over time, it remains vast, large enough to fit Earth within its boundaries. In July 1994, the comet Shoemaker-Levy 9 collided with Jupiter's southern hemisphere. This event marked the first time a cosmic impact with a planet was directly observed. Without Jupiter, the comet could have reached Earth, triggering an explosion even more powerful than the asteroid impact that wiped out the dinosaurs. Due to its immense gravitational influence, Jupiter behaves like a miniature planetary system, boasting 92 confirmed moons. Io is covered in active volcanoes that eject sulfur and sulfur dioxide, giving the Moon its distinctive yellowish hue. The New Horizons spacecraft captured this spectacular moment when the northern volcano Vashtar erupted, sending lava and ash into space. Ganymede is the only known moon with its own magnetic field, suggesting the presence of a liquid metallic core. Europa is a key candidate in the search for extraterrestrial life, as its icy surface is believed to conceal a vast subsurface ocean of liquid water. Its crust consists of fractured ice streaked with dark lines, likely caused by minerals and chemical compounds rising from the hidden ocean below. Alpha Centauri. Located 4 light-years away, this star system is the closest to our solar system, making it a top priority for astronomy and future space missions. It consists of 3 gravitationally bound stars: Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Orbiting Proxima Centauri. Proxima Centauri is one of the closest known exoplanets to Earth, situated within its star's habitable zone. This rocky planet, with a size and composition similar to our own world, is believed to have temperatures that could allow liquid water to exist. The thought of exploring this distant world is thrilling. Since its star is much closer than our Sun, it would appear larger in the sky, though its dim glow would cast a softer light due to its red dwarf nature. If Proxima Centauri has a weak atmosphere, it would create a stunning natural display. Its daylight would resemble a never-ending sunset, with a diffuse reddish glow stretching across the sky. At the same time, the dim lighting and darker sky would allow for a breathtaking view of the surrounding stars. If the planet is tidally locked to its star, one hemisphere would remain in perpetual daylight, while the other would be shrouded in eternal darkness. Without a strong magnetic field, Proxima Centauri would be exposed to intense stellar winds, likely producing massive auroras glowing in shades of red and green. If its atmospheric density is sufficient and water is present, liquid reservoirs could exist in regions with mild temperatures. There has been speculation about the presence of oceans, lakes, or underground water reserves. Tectonic and geothermal activity could drive volcanic eruptions and seismic events, forming clouds with unusual shapes. Likewise, the planet's surface is likely dotted with mountains and craters left behind by meteorite impacts.
WASP 12b.
Orbiting dangerously close to its star, this exoplanet reaches scorching temperatures of up to 2,500 degrees Celsius or 4,500 degrees Fahrenheit. Absorbing 94% of its star's light, it is considered one of the darkest astronomical objects, reflecting so little light that it appears nearly black. Under this extreme heat, it is slowly being consumed by its star, with its atmosphere gradually dissipating into space. The star's gravitational pull also distorts its shape, giving it an oval form resembling a rugby ball. Helix Nebula. Located about 650 light-years from Earth in the constellation Aquarius, this structure consists of the remnants of a sun-like star that has exhausted its nuclear fuel. Its resemblance to a giant eye has earned it the nickname Eye of God. At its core, the star has become a white dwarf, causing the surrounding gases to glow in shades of blue and red. Drog. Positioned roughly 2,300 light-years from Earth, this exoplanet orbits a pulsar. It ranks among the smallest exoplanets ever detected, an outlier in a category where planets tend to be significantly larger. Additionally, it was the first exoplanet discovered orbiting a pulsar, proving that planets can exist in some of the most hostile environments. Due to its proximity to the pulsar, it is bombarded with constant high-energy radiation, creating extreme conditions that make life highly unlikely.
Oumuamua.
Detected in 2017, it is the first known interstellar object observed passing through our solar system. Its hyperbolic trajectory suggests an origin in another star system, having traveled through interstellar space for millions of years. Observations indicate an elongated shape with a length-to-width ratio of up to 10:1, an extremely rare characteristic. As Oumuamua moved away from the Sun, its unexpected acceleration sparked speculation about a possible connection to an extraterrestrial civilization. Other hypotheses propose that it is a fragment from a planet or asteroid. (67P/Churyumov-Gerasimenko). This comet gained fame in 2014 when ESA's Rosetta probe successfully entered its orbit and deployed a lander, marking the first mission to accomplish such a feat. After a decade-long journey through the solar system, the mission finally reached its target. These images were captured using advanced cameras designed to withstand extreme conditions and record intricate details with high precision. Rosetta discovered complex organic molecules, including glycine and phosphorus, on 67P, supporting the idea that comets may have delivered organic compounds to early Earth. In this short video, the comet's surface is visible, covered in dust, with traces of cosmic rays streaking through. Red ribbon. Echoing through time, this stellar remnant tells the story of a colossal explosion that occurred around the year 1006 in the constellation Lupus. It was an exceptionally bright supernova, witnessed by Chinese, Japanese, Arab, and European astronomers. The red streak is part of the supernova's expanding shockwave, composed of interstellar gas heated and ionized by the explosion.
TRES-2b.
This gas giant is considered the darkest exoplanet ever discovered, reflecting less than 1% of the light it receives. The reason for its extreme darkness remains unknown, though scientists suspect its atmosphere contains elements that absorb light rather than reflect it. Despite this, its atmosphere may emit a faint reddish glow, generated by the heat trapped on its surface due to its proximity to its star. Saturn. Made mostly of hydrogen and helium, this gas giant shares similarities with Jupiter, but is significantly less dense. Its most striking feature is its iconic ring system, composed of countless ice and rock particles. With 145 confirmed moons, Saturn hosts a diverse range of natural satellites, varying in size and composition. The largest Titan has a thick nitrogen-rich atmosphere with traces of methane and other compounds. Its surface is home to rivers, lakes, and seas of liquid methane, and scientists suspect an ocean of water may exist beneath its frozen crust. Though much smaller, Enceladus stands out due to the plumes of water and vapor erupting from fractures in its icy shell. Its terrain features cracks, folds, and ridges, clear signs of remarkable tectonic activity. Supernovas. These powerful stellar explosions occur at the end of a massive star's life, or within a binary system, releasing an immense amount of energy. They reach peak brightness in the days following the explosion, sometimes becoming visible to the naked eye if they occur within our galaxy. During a supernova, the star's core compresses so intensely that its atoms break down, potentially leading to the formation of either a neutron star or a black hole. Years after the explosion, the remaining material expands outward, forming a growing nebula. One notable example is Cassiopeia, the remnant of a supernova that erupted roughly 300 years ago in the constellation Cassiopeia. KOI 4878.01. Though not yet confirmed, this exoplanet is estimated to be 1,100 light-years away and may be the most Earth-like world ever discovered. Its orbital period lasts 449 Earth days, with a mass greater than our planet's, implying slightly stronger gravity. Additionally, it orbits its star at a greater distance than Earth does from the Sun. If its atmosphere were rich in greenhouse gases, it could potentially sustain a climate similar to that of our own world. Hypothetically, this exoplanet might feature vast oceans, icy polar regions, and lush continents in temperate zones. Should KOI 4878 be confirmed, such conditions could support some form of life. Although not necessarily the case, the planet's greater distance from its star might result in dimmer starlight compared to Earth. Fluctuating temperatures, regions exposed to intense radiation, and deep shadows in others, combined with high tectonic activity, would shape the evolution of its species. Flamifolia would be a low-growing plant with spiraled leaves that shimmer in golden hues under the light of its star. Obscuravox are predators with pitch-black skin that absorbs all light, making them appear as living silhouettes. Thanks to its skin, it vanishes into any dark corner, becoming nearly invisible. Even under direct light, it remains difficult to detect since it reflects no shine at all. Pteroclypus is a large quadrupedal herbivore with a segmented shell that deflects light, offering protection from predators. It feeds on the thick leaves of Absorbaluxa, thriving in plains and rolling hills. Crustacellars are four-legged creatures with glowing crests used to send signals and communicate within their herds. The intensity of their bioluminescence reflects their emotional state. Plumiferax are mammals with long tails covered in bioluminescent feathers, which they use to attract mates. These oversized feathers also help regulate body temperature, dissipating heat in warm climates or providing insulation in colder environments. Infernopelids are stocky, low-built beings that inhabit volcanic regions, their legs shielded by a natural ceramic-like layer. They can consume boiling water without harm, thanks to the resilience of their digestive system. Pluto. A dwarf planet located in the Kuiper Belt, a distant region filled with frozen cosmic bodies. In July 2015, NASA's New Horizons mission became the first probe to fly past Pluto, sending back detailed images and data. The mission revealed that Pluto has ice mountains towering up to 3,500 meters, 11,000 feet. Its reddish hue comes from tholins, complex organic molecules formed when ultraviolet radiation from the sun interacts with methane in its atmosphere. Styx, one of Pluto's 5 known moons, likely formed after a collision with another celestial body. Mercury. The closest planet to the Sun, it has the shortest year in the solar system, completing an orbit in just 88 Earth days. Despite its fast orbit, it rotates on its axis very slowly, taking 59 Earth days to complete one full turn. Lacking a substantial atmosphere, Mercury experiences extreme temperature swings, soaring to 430 degrees Celsius, 806 degrees Fahrenheit, during the day and plummeting to -180 degrees Celsius, -292 degrees Fahrenheit at night. Its surface closely resembles that of the Moon, heavily cratered from ancient impacts that shaped the early solar system. It is home to one of the largest craters in the solar system, Kelloris Basin, spanning approximately 1,550 kilometers, 960 miles, in diameter. Galactic filament. These are the most colossal structures in the universe, stretching hundreds of millions of light years and composed of galaxies, gas, and dark matter, weaving an unimaginable cosmic web. Within this vast network, galaxies and clusters align along filaments, leaving behind immense empty regions known as cosmic voids. Scientists believe dark matter makes up the majority of mass in these filaments, providing the gravitational pull that holds them together. Uranus. The 7th planet in the solar system, this gas giant is recognized for its extreme tilt and bluish-green hue. Its unusual axial tilt causes each pole to experience 42 years of continuous sunlight followed by 42 years of total darkness. The atmosphere consists mainly of hydrogen and helium, with traces of methane that absorb red light and reflect blue. Thirteen narrow rings encircle the planet, made up of ice particles and dark dust. At least 27 moons orbit Uranus, named after characters from the works of Shakespeare and Alexander Pope, including Titania, Ariel, and Miranda. Sombrero Galaxy. Roughly 28 million light-years away in the constellation Virgo, this galaxy bears a striking resemblance to a Mexican sombrero. It stands out as a spiral galaxy with a sharply defined disk and bulge, an uncommon feature in the cosmos. At its core lies a supermassive black hole with a mass equivalent to 1 billion suns, making it one of the largest detected in the nearby universe. Although it appears relatively small from our vantage point, its diameter spans 50,000 light-years, comparable to that of the Milky Way. The Moon. Earth's only natural satellite, and the first astronomical body ever visited by humans. It is unusually large in proportion to its host planet, measuring about 1/4 of Earth's size, an uncommon ratio in the solar system. Without the Moon, Earth's axial tilt would fluctuate dramatically, leading to extreme climate shifts that could hinder stable life development. The so-called seas, which cover about 16% of the lunar surface, formed when ancient volcanic eruptions filled craters with lava. The Sea of Tranquility became the historic landing site of Apollo 11 in 1969, when Armstrong and Aldrin became the first humans to set foot on the Moon. Bubble Nebula. Located in the constellation Cassiopeia, this glowing nebula has a near-perfect spherical shape, resembling a delicate bubble. Powerful stellar winds from a massive hot star within its core drive its gradual expansion. Shades of red, green, and blue indicate the presence of hydrogen, oxygen, and sulfur, gases that radiate under the intense energy of the central star. Einstein Ring. Captured by the Hubble telescope, this phenomenon occurs when light from a distant galaxy bends into a circular shape due to the gravitational influence of a galaxy cluster. It is a direct prediction of Einstein's general relativity, which states that massive objects warp spacetime, altering the path of light passing near them. Neptune. The outermost planet of the solar system, this gas giant stands out with its deep blue hue. Its ring system is thin and faint, composed of dust and ice particles, barely visible from a distance. The planet's distinctive color comes from methane in its atmosphere, along with an unidentified compound that enhances its vibrant tone. Neptune's immense gravity allows it to capture and retain passing objects. So far, 14 moons have been identified. Among them, Triton is the largest and unusual for its retrograde orbit, suggesting it was likely captured from the Kuiper Belt. This frozen moon features nitrogen geysers on its surface, hinting at ongoing geological activity and the possible presence of a subsurface ocean. Kuiper Belt. Beyond Neptune's orbit lies this vast region of the solar system, home to millions of ice-covered bodies. These frozen remnants from the system's formation have remained nearly unchanged for billions of years. It contains several dwarf planets, including Pluto, Haumea, Makemake, and Eris. Haumea's outer layer is composed of crystalline water ice, giving it a highly reflective appearance. In 2017, astronomers discovered that Haumea has a ring around its equator, marking the first confirmed ring system around a dwarf planet. Eris, while smaller in diameter than Pluto, is more massive. Its surface is believed to be coated with a frozen mix of methane and nitrogen. Arrokoth is the most distant cosmic object ever visited by a spacecraft, explored by NASA's New Horizons mission after its historic flyby of Pluto. Its two lobes likely merged slowly in the distant past, avoiding a catastrophic collision. V838 Monocerotis. Located in the constellation Monoceros, this star stunned astronomers in 2002 with an unusual outburst that dramatically increased its brightness before fading. It produced a light echo that reflected off surrounding interstellar dust, captured in breathtaking images by the Hubble telescope. Unlike supernova, the explosion did not destroy the star. Scientists suspect it resulted from a stellar merger. Milky Way. Home to our solar system, This vast assembly of stars, gas, dust, and dark matter contains between 100 billion and 400 billion stars. It is a spiral galaxy with a dense central bar of stars and sweeping spiral arms extending outward. Most of the Milky Way's mass consists of dark matter, an invisible and enigmatic substance that neither emits nor absorbs light, yet exerts a strong gravitational pull. In about 4 billion years, the Milky Way and Andromeda will collide, merging into a single galaxy, likely elliptical. At night, the Milky Way appears as a glowing band, where countless distant stars blend together into a continuous radiance rather than individual points of light. According to Greek mythology, the goddess Hera spilled milk while nursing Hercules, scattering it across the sky and forming the band of the Milky Way. Ceres. This dwarf planet is the largest astronomical body in the asteroid belt, located between the orbits of Mars and Jupiter. It is one of the few places in the solar system showing evidence of water ice, with the possibility of an ocean beneath its frozen crust. Unlike most objects in the asteroid belt, Ceres exhibits signs of geological activity, including unique features like ahuna mons. There is evidence of cryovolcanism, a type of volcanic activity where cold materials like water and ammonia are expelled instead of molten rock. In Achater crater, scientists observed mysterious bright spots, later identified as salt deposits, likely formed after the evaporation of salty water. Quasars. These extraordinarily bright and distant cosmic phenomena are found at the centers of active galaxies. They derive their immense energy from supermassive black holes consuming vast amounts of gas and dust, emitting powerful radiation from their accretion disks. Observing quasars is like looking into the past, as some existed over 10 billion years ago, not long after the Big Bang. Many of them produce jets of charged particles that shoot from the poles of the black hole at speeds approaching the speed of light. Here is an illustration of a blazar, a quasar-like object with relativistic jets aimed almost directly at Earth, making it appear exceptionally bright from our perspective. Andromeda Galaxy. The closest spiral galaxy to the Milky Way, it lies approximately 2.5 million light-years away. With an estimated diameter of 220,000 light-years, it is nearly twice the size of our own galaxy. Containing around 1 trillion stars, almost double the number in the Milky Way, it boasts an enormous stellar population. At its core, Andromeda harbors a black hole with a mass of roughly 100 million suns, influencing the arrangement and motion of surrounding stars. Quasistar. Imagined as a cosmic giant, this theoretical stellar object would surpass the size of any known star in our universe. They are believed to have existed in the early cosmos, shortly after the Big Bang, when conditions favored their formation. These massive entities may have emerged after the collapse of an enormous star, forming a black hole while its outer layers remained intact. As the black hole devoured nearby matter, it released vast amounts of energy, sustaining the quasi-star for a brief period. Butterfly Nebula. Its two wings extend in opposite directions, a symmetry created by the violent ejection of material from the dying star at its center. The core that shaped this nebula is an extremely hot white dwarf, though it remains hidden behind thick clouds of dust. Pleiades. Located 440 light-years away, this cluster is known as the Seven Sisters due to its 7 stars visible to the naked eye, though it actually contains hundreds more. Its most prominent stars are hot, young, and massive, including Alcyone, Maia, Electra, and Merope. Easily seen without equipment from rural areas on Earth, a telescope reveals many additional stars within the cluster. Betelgeuse. Situated in the constellation Orion, this massive star is instantly recognizable by its deep orange-red hue. It is nearing the end of its life cycle, having exhausted the hydrogen in its core, a process that will eventually lead to a supernova. Among the largest stars in our galaxy by volume, it dwarfs the Sun, spanning hundreds of times its size. Neutron stars. Among the densest objects in the known universe, these stars form when a massive star exhausts its fuel and explodes in a supernova. Despite having a mass between 1.4 and 2.16 times that of the Sun, their diameter is only about the size of a city, making them incredibly compact. Their density is so extreme that a single teaspoon of neutron star material would weigh billions of tons on Earth. Magnetic fields surrounding these stars can be trillions of times stronger than Earth's. In a binary system, 2 neutron stars gradually lose orbital energy by emitting gravitational waves. Over time, This energy loss causes them to spiral closer until they eventually collide and merge. This violent event generates exceptionally bright and highly detectable explosions known as kilonova. Cat's Eye Nebula. Distinguished by its intricate and symmetrical structure, this nebula features multiple layers of gas, material knots, and patterns that resemble delicate shells. Its interior contains dense gas concentrations, though their exact formation and purpose remain a mystery. Venus. The second planet from the Sun shares many similarities with Earth, but harbors an extremely hostile environment, with extreme temperatures at both poles. From space, it appears shrouded in thick, white-yellow clouds, reflecting sunlight off its dense atmosphere. Primarily composed of carbon dioxide with sulfuric acid clouds, its atmosphere is highly toxic. Its rotation is remarkably slow. One Venusian day lasts 243 Earth days, making it even longer than its 225-day year. A world dominated by volcanic activity, it is covered in vast lava plains. Scientists believe its crust may contain thousands of volcanoes, some of which could still be active.
K2141b.
Roughly 200 light-years from Earth, in the constellation of Aquarius, lies this incredibly scorching and inhospitable exoplanet. It's a rocky world, comparable in size to our own, yet it orbits much closer to its star, turning it into a true lava planet. K2141b experiences a rock cycle. Minerals vaporized from its molten surface rise into the atmosphere, cool down, and then fall back as solid rock rain. One side is perpetually locked facing its star, creating a blistering hot hemisphere, while the other remains shrouded in darkness and freezing cold. Hickson Compact Group. Approximately 300 million light-years from Earth, this cluster contains elliptical, spiral, and irregular galaxies that are remarkably close to one another in cosmic terms. Such diversity in such a compact space is unusual. Their proximity triggers gravitational interactions that distort their shapes and cause them to exchange stellar material. As a result, within the next billion years, they are likely to merge into a single colossal elliptical galaxy, forming an immense celestial structure. J1407b. Found in the constellation of Centaurus, this planet stands out due to its massive ring system, which is about 200 times the size of Saturn's rings. If it were located where Saturn is, its rings would be visible from Earth, appearing far larger than the full moon in the night sky. TRAPPIST-1. Nestled within the constellation of Aquarius, this star system hosts at least 7 planets orbiting an ultra-cool dwarf star. All of its planets are rocky, an uncommon trait, as most planetary systems feature a mix of gaseous and terrestrial worlds. TRAPPIST-1e, TRAPPIST-1f, and TRAPPIST-1g reside in the star's habitable zone, where temperatures could allow for the presence of liquid water. Due to the star's relatively low temperature and energy output, these planets, despite their close orbits, do not experience extreme heat conditions. Stephenson 2-18. This colossal red hypergent ranks among the largest stars ever observed, surpassing even the renowned VY Canis Majoris in sheer size. Its estimated radius is about 2,000 times that of the Sun. If placed at the center of our solar system, it would extend all the way to Saturn's orbit. At some point, it is expected to explode as a supernova, leaving behind a stellar remnant, possibly a neutron star or a black hole.
HD 189733b.
Beneath its striking blue appearance, this exoplanet fascinates astronomers with its extreme conditions. Locked with one side always facing its star, the drastic temperature contrast between day and night generates powerful winds that attempt to balance the heat. Its atmosphere contains silicate particles, which vaporize under the scorching daytime temperatures, forming tiny droplets within the clouds. Carried by supersonic winds to the night side, these droplets condense and descend as a rain of molten glass. Pandora Cluster. The collision of 4 galaxy clusters, merging over 350 million years, has resulted in this chaotic and complex structure. It stands out for its unusual distribution of dark matter, which stretches across the cluster, appearing in unexpected locations. Through gravitational lensing, it acts as a cosmic magnifier, revealing galaxies that formed shortly after the Big Bang. Dark matter. This enigmatic form of matter makes up roughly 27% of the universe, yet it neither emits, absorbs, nor reflects light, rendering it invisible to conventional telescopes. Its unseen filaments have shaped the cosmos like a hidden backbone, drawing invisible matter and forming the large-scale structure of the universe. Unlike ordinary matter, composed of particles like protons, neutrons, and electrons, dark matter is believed to consist of exotic particles, such as wicks or actions. On the other hand, there is dark energy, which accounts for about 68% of the universe and appears to be driving its accelerating expansion. Unlike dark matter, which pulls things together, dark energy exerts a force pushing space outward in all directions, speeding up the universe's growth. Wormholes. These theoretical portals linking distant points in space-time are allowed by Einstein's general relativity, though their actual existence remains uncertain. To keep a wormhole stable, a form of exotic matter would be required, one with properties that defy the known laws of physics. If, hypothetically, a traversable and stable one could be created, it would appear from the outside as a distortion in space. Looking directly at it, we would see a sphere reflecting a distant region of the universe, like a window to another place or time. Approaching and peering inside, it would resemble a tunnel, not a physical space, but a compressed representation of space-time itself. Astronomers have examined images of galaxies and stars, searching for distortions that might hint at wormholes, but so far, all observed anomalies have been explained by black holes or other massive celestial objects. Earth. The only known world with life, positioned within the habitable zone of the solar system, where conditions allow liquid water to exist. From space, it appears as a striking blue sphere due to its vast oceans and the scattering of light in the atmosphere, a phenomenon unique within the solar system. Over 4.5 billion years, its climate, geology, and atmosphere have evolved in extraordinary ways, creating a complex environment that has fostered immense biodiversity. Earth has experienced various geological eras, from its volcanic origins to ice ages, each shaping its surface and influencing the evolution of life. This planet is exceptional because it possesses the perfect combination of conditions: an optimal distance from the sun, an oxygen-rich atmosphere, liquid water, a protective magnetic field, and a diverse chemical composition. All these factors have enabled the emergence of complex life, something that, so far, remains unparalleled in space exploration. R13601. Deep within the large Magellanic Cloud, this blue hypergent stands out for its colossal size and staggering luminosity. With a mass approaching 197 times that of the Sun, it has led scientists to rethink stellar formation theories, challenging the previous 150 solar mass limit. Its brilliance is 4.7 million times greater than that of our Sun, radiating in just 4 seconds the same amount of energy the Sun produces in an entire year. However, its existence is fleeting, lasting only a few million years before collapsing, far shorter than the Sun's 10 billion-year lifespan. Tabby's star. Located roughly 1,500 light-years away, this star gained fame in 2015 due to its unusual brightness fluctuations. It experiences irregular dips of up to 22%, an anomaly for a star of its type. Most brightness variations in stars are caused by orbiting planets, but Tabby's fluctuations are far too erratic to fit that pattern. With no definitive explanation, some propose that the phenomenon could be linked to a possible alien megastructure, such as a developing Dyson sphere. Another theory suggests that clouds of dust orbit the star in irregular trajectories, sporadically blocking part of its light. Antimatter star. This would be a star composed primarily of antimatter rather than regular matter. In theory, it would emit light and heat like any other star, but interactions with the surrounding matter-based universe would trigger explosive reactions. So far, no direct evidence of antimatter stars has been found, but if they exist, they would revolutionize our understanding of the cosmos. Their discovery would suggest that antimatter can persist in a stable form, or that certain regions of the universe are made entirely of it. Such a breakthrough could reshape our understanding of physics and technology, potentially paving the way for antimatter as an energy or propulsion source. Cygnus Loop. Hidden deep in the cosmos, this colossal cloud was born from a supernova that lit up the sky between 10,000 and 20,000 years ago. Spanning 120 light-years across, it covers an area equivalent to 6 full moons, as seen from Earth. Part of this structure includes the Veil Nebula, a region distinguished by its intricate filaments of ionized gas and dust. It resembles a living painting, where the vivid colors arise from chemical elements glowing as they interact with radiation. Hypernova. Releasing up to 100 times the energy of a typical supernova, these cataclysmic events unleash immense radiation in just a few seconds. They occur when a star more than 30 times the Sun's mass collapses at the end of its life, forming a black hole at its core. The energy expelled hurls material and interstellar gas at extreme speeds, reshaping regions of space across dozens of light years and potentially obliterating nearby planets. Though rare in the universe, hypernova play a crucial role in cosmic chemistry, producing and dispersing heavy elements like iron, nickel, and gold, enriching the interstellar medium. Omega Centauri. Standing out as one of the largest star clusters, it contains around 10 million stars. With an estimated age of 12 billion years, it ranks among the oldest objects in the Milky Way, a relic from the early universe. Its brightness allows it to be seen without a telescope, appearing as a hazy patch in the southern sky under clear conditions. In Omega Centauri, stars are packed much closer together than in our region of space, creating an environment vastly different from our own. Large Magellanic Cloud. Appearing as a faint mist, this galaxy is visible to the naked eye in the southern hemisphere, within the constellations Dorado and Mensa. At a distance of 160,000 light-years, it is considered relatively close as a satellite galaxy of the Milky Way. Inside it lies the Tarantula Nebula, an active star-forming region hosting massive stars like R136A1. So bright is this nebula that, if placed at the same distance as the Orion Nebula, it would cast shadows on Earth's surface. IC1101. A billion light-years away, this supergiant elliptical galaxy captivates astronomers as one of the largest ever discovered. It is estimated to contain around 100 trillion stars, vastly outnumbering the Milky Way's 200 to 400 billion stars. With a diameter of 6 million light-years, it is roughly 60 times the size of our galaxy. At its core lies a supermassive black hole, ranking among the largest in the known universe. KBC Void. Recognized as one of the most expansive cosmic voids, it would take an octillion solar systems to fill its volume. Despite being called a void, this region still contains galaxies, dark matter, and interstellar gas, though its density is significantly lower than in other parts of the universe. Some theories suggest that the Milky Way and the Local Group might be near the center of this void, potentially affecting our cosmological observations. The presence of such a low-density area nearby challenges the cosmological principle, which assumes the universe is uniform on large scales. Black Eye Galaxy. This galaxy exhibits a rare phenomenon: two gas disks of equal mass rotating in opposite directions, hinting at a past interaction with another galaxy. Its distinctive black eye appearance comes from a massive band of dark dust crossing its core, partially obscuring the starlight. Gamma-ray burst. Like a cosmic whip, this brief yet violent explosion releases electromagnetic radiation in the form of gamma rays, the most energetic light known. It occurs when two neutron stars merge, or when a neutron star collides with a black hole, as well as during the collapse of massive stars. Most gamma-ray bursts originate in distant galaxies, meaning we detect them long after they have already occurred. Some scientists have theorized that a nearby gamma-ray burst could have triggered a mass extinction millions of years ago by damaging Earth's ozone layer. In rapidly spinning stars within young galaxies, longer duration gamma-ray bursts may occur. When a star's core collapses under its own gravity, a black hole forms. Matter falling toward the black hole is propelled toward the poles, creating energetic jets that travel at the speed of light. Rho-Ophiuchi Cloud. Located about 460 light-years away in the constellation Ophiuchus, this is one of the closest star-forming regions to Earth. Here, clouds of gas and dust collapse under gravity, forming dense cores that eventually ignite into new stars. Crab Nebula. Born from a stellar explosion in 1054, this supernova remnant was documented by Chinese and Arab astronomers. At its core lies the Crab Pulsar, a rapidly spinning neutron star that emits streams of particles known as a pulsar wind. Horsehead Nebula. Its darkness is caused by dense clouds of gas and dust that obscure the background starlight, creating a striking silhouette against the Orion Nebula. It is visible due to the illumination from Sigma Orionis, a massive star located outside the nebula's frame, which lights up the surrounding gas. Part of a vast system of molecular clouds and nebula in the Orion constellation, it belongs to a complex that includes the Orion Nebula and the Flame Nebula. Brown dwarfs. Nicknamed failed stars, they form similarly to stars, but lack the mass to sustain hydrogen fusion, making them more akin to giant planets. Due to their low brightness, brown dwarfs emit heat rather than light, making them difficult to detect with conventional telescopes. They cool gradually over billions of years, allowing them to persist for exceptionally long periods. Ring nebula. Formed when a sun-like star reached the end of its life, it expelled its outer layers, creating a glowing ring of gas. At its center lies a white dwarf, emitting ultraviolet radiation that illuminates the surrounding nebula. This event foreshadows what will happen to the Sun in about 5 billion years when it depletes its nuclear fuel. GJ1214b. Classified as a super-Earth, this exoplanet orbits a red dwarf about 40 light-years from Earth. With an atmosphere rich in water vapor, methane, and thick clouds, it is considered a possible ocean world, with nearly 75% of its mass consisting of water in various states. However, this has not been confirmed yet. Further studies are needed to determine whether it has a liquid surface or if its water exists in other forms. Ursa Majoris C. This exoplanet orbits the star 47 Ursa Majoris, located in the constellation Ursa Major, roughly 46 light-years from Earth. A gas giant similar in size and composition to Jupiter, it follows a more distant orbit around its host star. As a massive gaseous world far from its sun, its atmosphere is likely composed of hydrogen, helium, and colossal storms. Its host system is estimated to be around 6 billion years old, making it significantly older than our solar system. Whirlpool Galaxy. A classic spiral galaxy about 23 million light-years away in the constellation Canes Venatici, easily visible from Earth. It harbors black holes and neutron stars that emit energy as they consume material from their stellar companions. NGC 5195, a smaller galaxy, is connected to the edge of one of its spiral arms, gravitationally interacting and triggering intense star formation. Fish Head Nebula. Like many emission nebulae, This region hosts numerous young stars in the process of formation. Its distinct coloration arises from an abundance of ionized hydrogen, which emits a red glow as its electrons recombine, along with traces of oxygen and sulfur. Stephan's Quintet. This compact cluster consists of 5 galaxies, 4 of which are locked in intense interactions, producing remarkable astronomical phenomena. They are caught in a gravitational dance, with tidal forces distorting their structures and triggering star formation within their arms. Orion Nebula. Easily visible to the naked eye in the Orion constellation, this nebula spans a vast 24 light-years across. Within it lies the Trapezium cluster, a collection of young hot stars that illuminate the surrounding gas. Essentially a stellar nursery, it is a site where hydrogen collapses under gravity, giving birth to new stars. Messier 82 Galaxy. An irregular galaxy in Ursa Major, it forms stars at an exceptionally rapid rate due to gravitational interactions with neighboring galaxies. This accelerated star birth generates intense stellar winds and frequent supernova explosions, creating a massive superwind that extends from its core. Heated dust from young stars radiates strongly in the infrared spectrum, making M82 shine brilliantly. Binary system. Two stars orbit a shared center of mass due to their mutual gravitational pull, a phenomenon observed in at least half of the stars in the Milky Way. These concentric ripples represent gravitational waves propagating through space at the speed of light. As the stars move closer, both the frequency and amplitude of these waves intensify, particularly in tight orbital configurations. In such systems, the stars can be so near that outer layers of material may transfer from one to the other. Twin Jet Nebula. Its bipolar shape, featuring two opposing lobes, arises from the presence of a central star within a binary system. From its core, spiraling jets of gas extend through the lobes, propelled in opposite directions by gravitational interactions.
Kepler 22b.
Located about 600 light-years away in the Cygnus constellation, this was one of the first exoplanets discovered within its star's habitable zone. With a radius 2.4 times that of Earth, this super-Earth might have a dense atmosphere capable of sustaining liquid water and supporting complex climate cycles. Its host star, Kepler-22, is a yellow dwarf similar to the Sun, though slightly smaller and cooler, suggesting moderate temperatures. As a large rocky planet, some theories propose that it could feature mountains and active geology, resembling certain terrestrial landscapes. Thus ends this fascinating journey through the universe. We have explored a cosmos filled with wonders, where perhaps, one day, we will find companionship beyond our own star or galaxy. Until the next stellar voyage.